Hello friends, welcome to FreeCAD tutorial, and in this tutorial we will model this flywheel, and this flywheel is also having the keyway with a screw for the locking, and you can see that I have already modeled it and it is matching with a reference 3D view of our part. I will show you how you can model this part in a FreeCAD with the help of a part design workbench. For this tutorial I am using the FreeCAD version 1.0, so you must have a FreeCAD version 1.0 or higher version. So I will close this file and create a new file. You can also visit my website macnexus.com, where I write articles and tutorials on FreeCAD, and you can also access my 3D part library of a FreeCAD. You can download the part from here and you can use in your projects with modifications. You can also access my 2D drawing library, where you can download these 2D drawings and you can create 3D models with respect to these drawings. You can also support me on ko-fi.com. You can buy me a cup of coffee. Your small support will help this channels to grow, and it will motivate me to create more awesome content on FreeCAD. You can find my ko-fi donation page link in a video description, as well as you can also see my ko-fi page URL on this header. So let's come back to our tutorial. So here I have created a new file, and I will activate my part design workbench, and now here I will create a body and then create a sketch. Now here we will create our first sketch. So we will create our first sketch on a right profile, means on a right plane, and here we will create this half portion and then we will revolve around this axis. So we will make this sketch symmetric. So for this I will use the polyline tool, and I will create a line and draw the approximate profile. Let's zoom it and create a rough profile, and then we will constrain it with the dimensions. So here you can see that I have created approximate profile, and now let's constrain it one by one. So first we will add a symmetricity constraint to these points. So click on the symmetricity constraint. Let's move our sketching icons, and now here I will select the symmetricity, select this point and this axis, and now add a dimensions, select a smart dimension, select this point and this point and give it 55 mm. Now the height of this is of 22.5, because this is a 45 and here I am giving the radius. And now let's also constrain the total height. So select a smart dimension, select this point and this point, and add a total height of 127. This is the half of the diameter 254, and here this line is horizontal, so I will select it and specify the horizontal constraint. and I will move this point to the upside, and let's add a symmetricity constraint to this point. So click on the symmetricity, select this point and this axis, and select a smart dimension and provide it value 9.5, and also make this point symmetric. So click on the again symmetricity, select this point and this axis. So this is a symmetric. Now we will provide the angle which is of 30 degree. So we will select the smart dimension, and here I will provide the 30 degree, and this outer one is of 25. So we will also make this symmetric. Click on the symmetricity, select this and this axis, and select smart dimension, select this point and provide the 25 mm. And now here we can see that this height is unconstrained, so we will fix it. So this point to this point dimension is of 15 mm. So select this point and provide it 15 mm. Now you can see that our sketch is fully constrained. Let's move the dimension so that you can clearly see it. This is a 25. Let's move angle to the outside. This is a 15 and this is of 9.5. So our sketch is fully constrained. We will close it, press 0 for isometric, and here we will select our sketch and click on the revolve, and here we wanted to revolve around the y-axis. So here I will select the y-axis, or you can click on the select reference and you can click on your own reference. So here instead of axis I have selected the edge. And now let's move to the next feature, which is to create a cut. If we go to the isometric view, so we can see here is a cut. So we will select the front face and click on the sketch, and here I will click on the project geometry and select this diameter, and from here I will switch to the wireframe, and once you rotate it you will see it. And now here I will create a circle, and I will select this created circle and this projected diameter and say it equal. And now we will create one more circle and select a smart dimension and provide this diameter of 218. You can cross check this dimension from drawing, and now I will close it, and let's switch to the flat lines view. And now we will select the sketch and create a cut of 5 mm. Select the sketch, click on the cut and say it 5 mm. Now let's move to the drawing view. So now the cut we have created here is the same on the other side. So we will mirror this. So click on this pocket and click on the mirror, and from here select the reference and select this exit plane. So you can see that our cut is got mirror on the both the side, and say OK. Now let's save our part. So let's make it R1, and now we will move to the next feature, which is, if we see here, in a main view of drawing. So here is a cut whose profile is given here. So this is a 29 and this is the R95, this is R10. So we will add this fillet radius later. First we will create a cut. So here I have a selected a face and click on the sketch, and for right orientation press 0. So we will make this front normal and we will create this cut. So let's switch to the wireframe view and let's create a 3-point arc. Select 3-point arc and create a arc, and now here I will select this point and this point and add a coincidence, and this radius is of 32. So I will select smart dimension and provide the 32, and here I will create one more radius and I will join the points. So from here select the one more radius and select the points and add a coincidence constraint. Now the outer radius is of R95, which we can see here. So we will select a smart dimension and make it R95. Now we will move this radius point and select a line tool and close our profile. And now we will give the angle. So this is a 29 degree. So we will give the 29, and this one will be 29 multiplied by 2, 58, and we will move it. And now let's see what is the unconstrained. So we can see that angle is given, but it is not constrained because this center point is not defined. So we will click on the line tool and we will make this line as a construction line, and we will select this line and give the parallel constraint. Same way we will move this point and create a line which will pass from this center to this point, and we will also make it a construction. And now select this point and this point by pressing the control key and add a parallelity. So here our sketch is fully constrained. Let's move the dimensions and close it. Now we will select our sketch and click on the pocket, and we will say it true all and say OK. So our cut is created, and now here is a fillet of R10. So we will add a fillet of R10 to the all four corners of our cut. So click on the fillet tool and select the edge and select this edge. So once you click on the edge, it is added here, and you can remove any edges by clicking on remove. Now select all the four edges and here fillet we wanted to give the 10 mm. Say OK. So you can see that fillet is created, and now we will provide one more fillet and we will polar pattern it. So if we go in a side view, so here we can see the fillet of R3. So we will click on the fillet and provide the value R3 and select this edge and this bottom edge and say OK. So you can see that fillet is created. Now we will polar pattern this all three: pocket, fillet, There are the two fillet, one is of R10 and this one is of R3. Now click on the polar pattern, and here we will define our axis. So be patient if FreeCAD takes some time. Now here you can see that y-axis is automatically selected, and number of instances I will give the 4. There are the 4 cuts, and say OK. So here is a FreeCAD is a recalculating, so have the patience. So you can see that the FreeCAD recalculated it, and transformation is succeed. Say OK. Now there is a keyway profile on our flywheel, and whose detail is given here. So now we will select this face and create this keyway profile. Let's save our model first, and here I will press my 0 for isometric view, and we will select the face and click on the sketch. And now here we see this front inverted, so for better orientation press 0, and we want to create the keyway in this way, so we will make this front cube normal. And now here I will create a circle, and I will create a rectangle here, and I will delete this horizontal line, and I will use the trim tool to remove the unnecessary geometry. Select this edge and also remove this arc. So this is the profile, and here is the width of a key is 6 mm. So we have to make this symmetric. Click on the symmetricity, select this point and this axis, select a smart dimension and give it a 6 mm, and here height is given is of 22. So we will select a line tool and create a horizontal line. Select this and add a coincidence. Select this and add a tangent. Select this horizontal line and make it construction. And now we will select a smart dimension, select this point and this point, and here we will add a dimensions 22 and define the diameter. Diameter is of 20. So here radius we are defining, so we will give it 10, and this you can see here diameter 20. Now we have a fully constrained sketch, total height 20, and this is the diameter 20. Now we will close it, and we will select the sketch and click on the cut. And from here we will say it true all and say OK. Now here is a screw, detail is given, and if we move here we can see is detailed. This is the M4, and this screw is on this diameter surface. So we will create a datum plane at a distance of 22.5. so we will select this top plane, and here you will get options create a datum plane, and in a Z directions define value 22.5, and we will switch to this front face, so we can clearly see that a tangent plane is created. And let's off the origin plane, and we will create our whole sketch on this plane. So here is a rebuild options, click on recompute, select the datum plane and click on the sketch. And now here we will project this edge, click on the project geometry and project it, and here click on the circle and create a circle on this axis and select smart dimensions, and this is of M4, so we will create a diameter 4 sketch, and position is of 8 mm from the edge, so we will select this edge and this diameter and provide the 8 mm. Now we will close it and we will hide this datum plane, and we will select this sketch and click on the hole wizard, and in a hole wizard we will define this parameter. So here we will select the isometric regular profile, and here I will define the dimensions 12 mm, and this is the threaded, and we will keep the class as it is and set it to the right hand, and here select the countersink, and now you will see the options. So diameter is of 8, and depth we will set 0.5, and now say OK. Now we will switch to the right view, and from here we will switch to the wireframe. So you can see that cut is created here, and now let's switch to the flat line. So this diameter is very small, so we will edit our hole and we will see what went wrong. So here isometric regular profile is there, and now here we will define the thread class, which is it took the M1. So let's select isometric regular profile, and from here in a drop down select the M4, because there is a tapping of a M4, and now it looks perfect. Say OK. Now here angle is given a 90 degree, and this is of 8 mm. So if this depth is looking too much, then we can also customize it from here, and instead here is a diameter, we will give the 8 mm, and for the depth is a 90 degrees given, and let's control the depth with a 0.5. Okay, so keep as it is, because if we give the depth, then this is increasing, so we will keep it as a 8 mm, and we will keep it 0, and we will say OK. So this is completes our model, and you can see that we have successfully converted it, and there are some minor details which you can provide, like chamfer is of 1 mm, C1 is given on the both the edges, so I will select it and give the chamfer 1 mm, say OK. Now press 0. So this completes our model, and it is matching with our isometric view. If we switch it to the right orientation, so you can see that it is a perfectly matching. So this tutorial is designed for the beginner user, and in this tutorial we have learned so many tools like mirror, polar pattern, datum plate, chamfer, fillet, etc. So this is all about this tutorial, how to model flywheel in FreeCAD. Thank you for watching, and thank you for your valuable time.